Therefore, next question is given that a metal block of mass 0.5 kg is placed on a plane inclined to the horizontal at an angle of 30 degree, and the coefficient of friction is point. What force must be applied to just prevent the block from sliding down the inclined plane? So let's just try to solve the first part. Right. And it's given that there is a metal block of mass 0.5 kg. So this is the first part that we are going to solve. Okay, so let's say this is the inclined plane on which there is a metal block of mass 0.5 kg, and the angle of inclination is 30 degree. This is the weight which is acting vertically downwards. This is its vertical components. This is its horizontal component. And this horizontal component is balanced by the normal reaction R. Okay, so this is 30 degrees. So this is also 30 degree. This is mg cos 30 degree. And this is mg sine 30 degree. Because the block is coming down on the inclined plane, so the force of friction is in the upward direction, and the coefficient of friction is given. So here coefficient of friction is the maximum force of friction divided by the normal reaction. So the force of friction is equal to nu into R, and R is balanced by the horizontal component, which is mg cos 30 degrees. So this is the force of friction. Now, if we have to prevent the block from sliding down the inclined plane, that means we have to apply the force in this direction. So this force gets added to the force of friction and should be equal to mg sine theta. So that means that the force we are going to apply gets added to the force of friction and becomes equal to the vertical component, that is mg sine theta. And now we have to find the force that we have to apply. So this is equal to mg sine 30 degree minus the force of friction, and the force of friction is nu into mg cos theta. So this is mg sine 30 degree minus mu into mg cos 30 degree. So the force of friction is equal to, as let's put in the value, mass is zero point 0.5 into 9.8, and value of sine 30 is half, minus nu is zero point 0.2 into 0.5, g is 9.8, and cos 30 is root 3 by 2. So if we substitute the value, so this force comes equal to 1.6 Newton. So 1.6 Newton is the answer for the first part. And let's move on to the second one, where we have to just move the block up the inclined plane. Okay, now in this case, we have to move the block up the inclined plane. Let's draw the free body diagram, rough sketch once again. This is the okay. This is mg cos 30 degree, mg sine 30 degree. This is now, because we have to move the block up the inclined plane, so the force of friction now is in this direction, and we have to apply the force in the upward direction. So here the force that we need to move the block up the inclined plane will be just, so in this case we have to apply the force in the upward direction, and now the force is equal, this force should be balanced by Now this force is equal to mg, should be equal to mg sine theta plus force of friction, because now force of friction is in the downward direction because the block is moving upward. So this is mg sine 30, and the force of friction is mu into r, and r is mg cos 30 degree. If you put in the values, so let's put in the values. Mass is 0.5, g is 9.8, sine 30 is half, mu is zero point 0.2, mass is 0.5, g is 9.8, cos 30 is root 3 by 2. So we it's just the opposite of the first case where we subtracted this nu into mg cos theta from mg sine theta. In this case, we are just going to add up, and if we add up, this force becomes, if we calculate the values, so this is equal to 3.299. So this is 3.299 in Newton. Okay, now let's move on to the third one, where we have to move it up the inclined plane with an acceleration of 20 centimeter per second square. Now the only difference here is that there is an acceleration as well. So let's draw the rough sketch once again. Now the block is moving up with an acceleration of, so here is an acceleration which is 20 centimeter per second square. Let's get this converted to meter per second square. So this is 20 centimeter per second square, which should be equal to 0.2 meter per second square. Now this is the mass which is acting vertically downwards. This is mg cos theta. Theta is 30 degree. So this is 30, and okay, because this is the vertical component mg sine theta. Now the acceleration is in the upward direction. So the force that we have to apply, so there is an additional force that we have to add to this force to move this block up an inclined plane with an acceleration of 0.2 meter per second square. So we have to just add this additional force with an acceleration to move this block up an inclined plane with an acceleration of 0.2 meter per second square. So this force comes out to be, mass is point A, this is zero point 0.2 plus this is 3.29. So block is already moving up with the inclined plane with this force. We have to just give the acceleration. So acceleration, for the acceleration we have to just give an additional force, which is zero point 0.5 into zero point 0.2 acceleration, and this is 0.10 plus 3.299, which is equal to 3.399 Newton. So this is the force with which block will move up with an acceleration of 0.2 meter per second square. With this, we are done with all the three parts of this question. Do like, share, and subscribe. Thank you for watching.